All right, Cody Miller, Rocky Mountain Team 2, Fire Behavior. So now we want to kind of look at what's going on currently out there on the fires. So in order to understand that, I showed the drought monitor earlier and talked about those long-term effects of that, like what a drought can do to those things. So what those have effects on are the fuels that are out there. So there's 5 types of fuels. You have fine dead, that is like grass that's dry or dormant or dead. You have 1-hour fuels, which is just your green grass, it's stuff you see in your lawn. Then you have your 10-hour fuels. These are sticks about the size of a pencil or a pen. And then you have your 100-hour fuels, which are the size of about a softball or a roll of masking tape. So think about a log or a branch about that size. And then you have your 1,000-hour fuels. Those are going to be about the size of a frisbee or a plate, like a paper plate or a dinner plate, or bigger. So think about those types of fuels and like how they would hold moisture. So the way we name them, the 1s, 10s, 100, 1,000 hours, well, why do you name them that way? Well, what that means is for the 100-hour fuels, it takes 100 hours for that thing to totally saturate or to totally dry out. So you do the math, 24 hours in a day, 100 hours, that's about 4 days. So it takes about 4 days for those softball-sized fuels to dry out or to saturate. So think about the 1,000-hour fuels. Now 24 goes into 1,000, that's a little bit more. Well, the math shows us it's about a month and a half. A little bit less than that, but it basically takes about a month and a half for those big fuels out there to totally saturate from a rain or a snow or to totally dry out. Now those 2 fuel types, the 100 and the 1,000, they are the ones that are most affected by the long-term drought we talked about earlier. And I'm going to show you some examples of like how those things burn. Those are the fuels that are driving these 2 fires. So this was probably a 100-hour right here. And as you can see, it burned completely up. And then once it started to get into the finer fuels, those 1s and 10 hours, it went right out. Next slide. This over here, that's a 1,000-hour. It's gonna burn for weeks and months, and it's just gonna like work its way through the duff and keep burning, and it takes a ton of water to get these fuels to go out. And what can happen is, as these get at the bottom of a drainage and we get a wind that comes up, and next thing you know, boom, it's gonna take off and it's gonna get up into these ladder fuels and move into it. And that's what's driving this fire. And as the humidities lay lower and the temperatures rise, that's when we see more of this. But right now, with the static weather we've been having and the wetter humidities we've been getting, the fire's kind of sitting there and containing itself and just burning in those 100s and 1,000-hour fuels. Meanwhile, the 1s and 10 hours, they're kind of keeping it in check. And that's the situation we're in right now.